Hello, my name is Garrett, Raska, and I lead our solutions engineering team here at Molecula. Today, we'll be showing you working with FeatureBase on a Jupyter notebook on a common use case we see, which is customer segmentation. So let's go ahead and dive right in. The first thing we're going to do is set up the notebook to communicate with FeatureBase. It is running on an EC2 instance in AWS. The node is 32 cores and 120 gigs of RAM. And the first thing we're going to do is import our Python library and connect through our gRPC API, which is hosted on 20101, seen here. And we are going to be working on a table that was already ingested, in this case, the CSEG table, or which is short for customer segmentation. And I'll be showing you some of the data that contains here in a moment. So let's go ahead and run this cell and set the notebook up and do a quick test query. So as you can see, that query took around 14 milliseconds and did a quick select count star from the customer segmentation table to produce a count that is 1,023,000,000 and some change. And that is the set we'll be working with today. Now let's take a closer look at one of the fields that we have. So we've got around 26 available fields, which you can think of as attributes or features, and each of those may contain a high degree or high cardinality amount of either strings, integers, etc. In this case, we went ahead and did a select distinct from the hobbies field, and you can see we've got around 200 or so strings that can be represented on any number of the records, just to give you an idea. Now let's go ahead and actually pull out with a select star 10 of those records, and we're going to load them into a pandas data frame. And as you can see, we have just general demographics information. Age, we have a bool field to represent how bulls will be in FeatureBase. City is a string, education in arrays, hobbies in array, income in an integer, and so on. Now, let's get to some of the use case. Oftentimes we see customers needing to do very complex queries on large data sets, and they may be using and or not clauses and looking for results that return in the hundreds of thousands. And so again, on this small node, we're going to start to do a select count star from the customer segmentation table, and we're just going to search for a particular age, a specific income as seen up here, and then we're going to give it the ability to choose skills, MS Office, or the skill Excel. So let's go ahead and execute this. And the first thing you'll notice, it still took around 250 milliseconds, a little high for us. But the return came out at 204,000 records meet these specific conditions. Now, we can do this and continue to add clauses to this, and this speed will remain the same. So let's go ahead and move on to some larger scale aggregations. We typically focus here because aggregations are a sore spot in some of these use cases because the sheer number of records that are already present and continuing to flow in. Now, we often see the need to do intermediary tables in the form of roll-ups or summaries. Those could take between 2 to 48 hours to days to some a few weeks in order to produce those roll-ups and to make them available for end users, in this case maybe BI tools such as visualizations or even ML and data science teams. So as you can see, let's go ahead and run a select sum on the income field, which we'll remember seen here contains all of the income integers present in the 1,023,000,000 records. So if I'm going to go ahead and run this, as you can see, instead of just pick a few of them, I just summed the entirety of the table. So all 1,023,000,000 were summed, took around 23 milliseconds, and you can see that sum here is a rather large number. Now, we can do the same thing for average as well, just to give you an idea. So here's the average. It seems like our table is doing quite well at around $100,000 average on income, etc. Now let's up the stakes a bit. So let me just flop over here to, I'm logged in on the node, and what I'm going to do is run a load script that is going to generate records at around 60,000 every few milliseconds or so and push those into the table live, and we're going to run those same queries. So let me kick that off. You can see we are creating, translating, and pushing those into the data store live. And just to show you that, we can go back up to our first query, which is the count all, And we should see this number jump. So instead of, yep, you can see it's going up by around 1 million records or so every so often. Yep, there we go. Now, as you can see, that didn't slow that query down. And we'll do the same thing on our, let's give it this complex condition one. So again, load on this box is coming in. We're ingesting at around 1 million records every 1.5 seconds. And we can still tackle those large-scale aggregations without any delay or any added latency. So that is one thing that we provide for our customers is throughput, the ability to, again, ingest these records and run these queries simultaneously. And let's take a quick look. Our script is still running, still going in, and let's just continue on. Another area that we help our customers is joins at scale. So the ability to do inner joins across a billion table to any other table can be quite difficult, especially with records flowing in. So let's go ahead and run this while our records are still going. And what we're doing here is a select count star, and we're going to start at our customer segmentation table, and then we're going to inner join that to our skills table, which has, let's do a quick look, around 25,000 records in it. And we're going to look for specific conditions available for hire and T1 hobby. So we're going to look for these on the skills table, anyone that's available for hire, and we're going to search through all of our 1 billion for those that are in the teaching field. And as you can see, query still took around 26 milliseconds. Remember, we are live ingesting at around 1 million records, 1.5 million records per second. And you can see the count return. Now let's continue moving down. We also see the ability, the need for the ability to do grouping and with large segmentations. So that would be considered a group by. So let's go ahead and select hobbies. We'll count star again from the customer segmentation table, and we're only going to interest in accounts that get above 2 million. So here you can see 30 milliseconds, and our hobbies come out to over, let's see, how many, 42 million in watchmaking, which is interesting. Slacklining, watching movies, again, group buys will return is just as fast as our aggregations as well. The last piece, we see the need to load this information into visualizations. So let's go ahead and run that. You can see we'll take that count from hobbies and skills and represent it, and in this case on a top K. So here are the highest skills that we see across our entire indices, or table rather, data entry, answering phones, billing, etc. Thank you for your time.